Okay, so let's work through the example we left off the last video with. So we're given the sine of angle theta is negative rad 3 over 3, and then we're told that angle theta is in quadrant 4 between 3 pi over 2 and 2 pi. Okay, so we're going to start out drawing a diagram here. So again, angle theta. If sine is negative rad 3 over 3, that means that sine is the ratio of the side opposite over the hypotenuse. And then we can use the Pythagorean theorem to find the missing side length. So the side adjacent is going to be rad 6. And if theta is between 3 pi over 2 and 2 pi, that means that theta over 2 is going to be between 3 pi over 4 and pi, which is going to put theta over 2 into quadrant 2. Okay, so if we want to find the sine of theta over 2, because theta over 2 is in quadrant 2, we know sine is positive in quadrant 2, so we're going to use the positive radical. So this is going to become 1 minus the cosine of angle theta all over 2. And then I'll go ahead and do the cosine of theta over 2 to the right just to get that set up. So again, because theta over 2 is in quadrant 2, we know cosine is negative in quadrant 2. So we're going to take the opposite of that radical, which is going to be 1 plus the cosine of theta all over 2. Okay, so we're just going to go ahead and plug in what cosine of theta is. So cosine of theta is adjacent over hypotenuse, which is rad 6 over 3. And because angle theta is in quadrant 4, we know cosine is positive in quadrant 4. So that's going to be 1 minus positive rad 6 over 3, which we're dividing by 2. And then we want to simplify that, multiplying the top and bottom by 3. So this is going to become the square root of 3 minus rad 3. Sorry, 3 minus rad 6 all over 6. And then to rationalize that denominator, I'm going to multiply the top and bottom by 6. So that's going to make the square root of 18 minus 6 rad 6. And then our denominator is the square root of 36, which is going to wind up becoming 6. And then for the cosine of theta over 2, we're going to do the same thing. It's going to be negative 1 plus the cosine of theta, which is rad 6 over 3 over 2. And then again, we're going to multiply the top and bottom by 3 underneath the radical. So we get the cosine of theta over 2 equal to negative the square root of 3 plus rad 6 over 6. And then to rationalize, we're going to multiply the top and bottom by 6, which makes the cosine of theta over 2 equal to negative 18 plus 6 rad 6 all over 6. All right, let's try this one next. This one's not going to apply to half angle formulas. We're actually going to see that it's going to apply to both the double angle formulas and the sum formulas that we looked at in the previous section. Okay, so directions here ask us to find the exact value of the cosine of the inverse sine of 3/4 plus 2 times the inverse cosine of negative 1/4. Okay, so the way that we're going to want to work this one out is we know that the inverse sine of 3 over 4 is going to correspond to some angle measure. So we're going to go ahead and call that angle alpha. And the inverse cosine of negative 1/4, again, we know the output for an inverse cosine is going to be an angle measure. We're going to go ahead and call that angle beta. So what this expression essentially becomes is the cosine of alpha plus 2 times beta, which this then becomes utilization of the sum formula for cosine. So we know the sum formula for cosine is going to be the cosine of the first angle, which is alpha, times the cosine of the second angle, which is 2 beta. And we take the opposite of our sign, which the opposite of the plus sign is minus, the sine of the first angle, alpha, times the sine of the second angle, which is 2 beta. Okay, so what we're going to have to do now is we're going to have to rewrite the cosine of 2 beta and the sine of 2 beta in terms of their double angle formulas. So we have the cosine of alpha. The cosine of 2 beta, it doesn't matter which of the 3 double angle formulas we use. I'm going to use the first one, which is cosine squared of beta minus sine squared of beta minus, and then we have the sine of alpha times the sine of 2 beta. So the double angle formula for sine is going to be 2 times the sine of beta times the cosine of beta. Okay, so what we need to do now is we need to come up with like ratios that correspond to each of these trig functions. Okay, so I'm going to go ahead and diagram that over to the right here. So for this inverse function here, if the inverse sine of 3 over 4 is equal to alpha, that means that the sine of alpha has to be equal to 3 over 4. And we know that because the ratio is positive, the angle has to be in quadrant 1. Okay, so our angle alpha here, sine is 3 over 4, so we know sine is the ratio of the side opposite over the hypotenuse, which using the Pythagorean theorem is going to make the side adjacent rad 7. Okay, so we can plug in for alpha, like the sine of alpha and the cosine of alpha, based on the side length relationships in that right triangle. So we know the cosine of angle alpha is going to be positive rad 7 over 4, again, because that angle is in quadrant 1. And we know that the sine of alpha is equal to 3 over 4. Again, that's positive because the angle lies in quadrant 1. Okay, to do our diagram for beta, we have the cosine inverse of negative 1/4 is equal to beta. So that means that the cosine of angle beta has to be equal to negative 1/4. So again, I know that that angle is going to lie in quadrant 2 because when the ratio is negative, the output for inverse cosine is in quadrant 2, but I'm just going to diagram like the regular right triangle here. So cosine is the ratio of adjacent over hypotenuse, which is using the Pythagorean theorem, making the side opposite rad 15. So if our angle is in quadrant 2, we know sine is going to be positive in quadrant 2, and cosine is negative in quadrant 2. Okay, so we're going to go ahead and plug in for sine and cosine of angle beta. So cosine of angle beta is negative 1/4 squared minus the sine of angle beta is opposite over hypotenuse, so that's rad 15 over 4, quantity squared. And then we're going to plug in for the sine of beta and the cosine of beta over here to the right as well. So we have 2 times the sine of angle beta, which is rad 15 over 4, times the cosine of angle beta, which is -1/4. Okay, so all we need to do now is go through and simplify this expression. So we get rad 7 over 4 times -1/4 squared is 1 over 16 minus rad 15 over 4 squared, which is 15 over 16, minus, then we have 3/4 times 2 times, whenever I multiply the last two quantities, we get negative rad 15 over 16. Okay, so we get rad 7 over 4 times -14 over 16 minus 2 times 3 is 6. So that's 6 rad 15 over 64 whenever we multiply across. So we get -14 rad 7 over 64 minus 6 rad 15 over 64. So that becomes -14 rad 7 minus 6 rad 15 over 64. And I see that both the numerator and denominator are divisible by 2. So that's going to make -7 rad 7 minus 3 rad 15 all over 32. And that expression right there is simplified. Okay, we'll look at the power reducing formulas in the next video.